Hello everyone, very good evening one and all. Welcome to the most comprehensive preparation platform for all competitive exams, BYJU'S Exam Prep. And warm welcome to the Score Booster NIELIT 2023 series. We have solved 10 questions of algorithms in the last class. By chance you missed, please watch it in the playlist. Today, let us solve 10 more top questions of algorithms. So, while late, join the session quickly and mark your presence. Please confirm my visibility and audibility, everyone. Hi Seshikala, good evening. Whoever have joined, please confirm my visibility and audibility. Am I visible and audible? Okay, so let us solve 10 more important questions of algorithms. Please download our BYJU'S Exam Prep app if you have not downloaded it, because there are many useful features that helps for your preparation. And guys, on 5th November, there is a national scholarship test through which you can avail up to 90% off on all our programs. And on 8th November, there is a workshop, live interactive workshop on our BYJU'S Exam Prep app taken by Joshit Singh sir. In this, Joshit Singh sir will discuss roadmap to secure AIR under 100 in GATE 2025. So without fail, register for both and avail the benefit. And this is the complete schedule, you can get it. So for 2024 aspirants, there is a crash course, and 2025 and 2026 aspirants, there is a long-term course. So you may enroll. This is the quick brief about me. I am Satya with all the credentials. Now, without any delay, let me present the very first question. Question number 11. Because 10 questions are already over in the last class. Today, question numbering starts from 11. If one uses straight two-way merge sort algorithm to sort the following elements in ascending order, then the order of these elements after second pass of the algorithm is. What would be your answer for this question? Given ten elements, so first division happens. 20, 47, 15, 8 and 9 will be one set. 4, 30, 40, 30, 12 and 17 would be in another set. These are further divided into 20, 47, 15 as one set, 8 and 9 as one set. Here in the same way, 4, 40, 30, 12, 17. Then these are divided as 20, 47, 15. Here 8, 9. Similarly, 4, 40, 30. 12, 17. Observe the division process. 20, 47, 15, 8, 9, 4, 40, 30, 12, 17. So this is division. Now merge sort, conquer by arranging in the order. So in pass 1, how you divide? They are only arranged. So 20, 47, 15 would remain same, 8 and 9, 4 and 40, 30 remain same, 12 and 17. Now in pass 2, these two are merged, 15, 20, 47, 8, 9 will not be merged here. Here 4, 30, 40 and 12, 17 remains same. So when you are merging, I think, wait, this is pass 1. Yeah. Now pass 2, merge this 15, 20, 47 and 8, 9. So 8, 9, 15, 20, 47 and here these two are merged. So it will be 4, 12, 17, 30 and 40. So this would be the outcome of the elements after second pass of the algorithm. So the right answer you will get is 8, 9, 15, 20, 47, 4, 12, 17, 30, 40. Option A. How we are dividing? They are only merged in the same order. Okay. Now, question number 12. What is the recurrence relation for worst case of quicksort and what is the time complexity in average case? So we want the recurrence relation for quicksort in worst case and time complexity in the average case. Actually, it should be T of n is equal to T of 2T of n minus 1. No. T of n minus 1 plus big O of n. This is the worst case time complexity, right? But average case time, worst case recurrence relation, but average case time complexity must be big O of n log n, isn't it? Everybody? So I think the second option must be big O of n log n. Option B only has the correct recurrence relation, right? So option B is the right answer. Worst case n square, right? Question number 13. The recurrence relation for Strassen's approach of 2 n by n matrices multiplication is Strassen's matrix multiplication recurrence relation. Do you know it? If not, please know. It may be asked as a question. It is 7t of n by 2 plus n square. Actually, it should be 8 with the regular multiplication method. Strassen reduced it to 7. So, the time complexity also will be reduced from big O of n cubed to big O of n to the power 2.81. This is the Strassen's matrix multiplication time complexity. Reduced number of multiplications with sudden sequence. This is the regular multiplication method. There 8t of n by 2, but here 7t of n by 2. Okay. Question number 14. Consider a hash table with 100 slots. Collisions are resolved using chaining method. Same question you have got yesterday. So you might think it is the same question. No. Here collisions are resolved using chaining method. Yesterday's question was using open addressing. Here it is using chaining method. If so, what is the probability that the first 4 slots are unfilled after first 4 insertions? In the chaining method, you have 100 slots. Total. The first 4 slots should be unfilled. So remaining you are having 96 slots. Using chaining method, in the same slot you can have as many keys as you want. So for the first insertion you have how many free slots? Possibilities 96. Even for the second insertion also 96. Third, fourth also 96. So what is the total probability? So total probability would be 96 into 96 into 96 into 96 divided by 100 to the power 4. But if you use any of the open addressing method, if one slot is occupied, means if collision occurs, we go for the next probe and we make sure we get the free slot. So there number of free slots from insertion to insertion keep reducing, but here it remains the same. So it is option A, using chaining method. Exactly Sashikala. Okay. Hi Dushyant Arya, hi Aarti Seaman and everyone. Clear? Let's go to question number 15. The number of movements required, movements means disk movements, required in the TARS of Hanoi problem with n square disks is how much? If there are one disk, just one movement. If you have 2 disks, then 3 movements. If you have 3 disks with 7 disk movements, you can shift disks from tower A to tower C. So, if you are having n disks, 2 to the power n minus 1 movements required. But here n square disks are given, so it would be 2 to the power n square minus 1 movements. So, option C should be the right answer. Option C should be the right answer. Right? Yep. Question number 16. Match the following problems with respective time complexities in best case. So, match these with best case time complexities. Quick. Merge sort. In best case, average case, worst case, the time complexity is n log n. So, option A you can actually eliminate here. Insertion sort. In best case it is n, in the average and worst cases it is n square. So, 2B. Binary search. In the best case, the middle element could be the key. So, it takes constant time complexity in the best case. And tars of Hanoi always exponential. So, it is 1D, 2B, 3C, 3A, 4C. Option B is the right answer. Got it? Question number 17. Suppose P, Q, R, S, T are sorted sequences having lengths 20, 24, so on respectively. They are to be merged into a single sequence by merging two sequences at a time. The number of comparisons that will be needed in the worst case by the optimal algorithm for doing this. Here we want number of comparisons. If there are two sequences, S1 of length m elements, sequence 2 of length n elements. Whenever you merge these two, number of comparisons would be how many? M plus n minus 1. M plus n minus 1. So, arrange these in the ascending order, however they are given in the ascending order, 20, 24, 30, 35, 50. Now, optimal merge says that merge the two minimum lists. So, 20, 24 when you merge, the number of, you will get 44 elements, but the number of comparisons would be 43. The next two minimum are 30 and 35. When you merge these two, you will get 65 elements list, but the number of comparisons would be 64. The next two minimum are 44 and 50. So, you will get 94 elements total, but the number of comparisons would be 93. Then you merge 65 and 94, you will get 159 elements list total, but the number of comparisons would be 158. Now, total comparisons we want. So, total number of comparisons would be 43 plus 64 plus 93 plus 158. Use the calculator. I am also using 43 plus 64 plus 93 plus 158. That is 358. So the right answer is option A. Option A is the right answer. Clear? Question number 18. If job J equal to J1, J2, J3, J4 are given job set, their processing time Ti is 1, 1, 2, 3 and the deadline are Di 3, 4, 2, 3. Maximum how many jobs can be done? The maximum deadline is 4, right? So what is the job you can do it by deadline 4? Job 2. So slot 3 to 4 is free because job 2 require only 1 unit of time. So job 2 let us schedule at 3 to 4. Now job 1 and job 4 are having the deadline 3. Job 1 if you schedule, it takes only 1 unit of time. Job 4 if you schedule, all the 3 units you have to give for job 4 only. So let us schedule job 1 at 2 to 3 slot. Now job 3 deadline is 2. Yes, job 3 you can do because job 3 you can do as well as job 3 you can do as well as job 4 also you can do. Suppose I schedule job 4. Job 4 require 3 units of burst. But do we have job 4 3 units of burst here? No. We have only 2 units of burst. Hence, job 4 you can't schedule, job 3 you can schedule. So, in the given time, we can complete maximum 3 jobs. So, maximum 3 jobs can be done. So, the right answer is option C. Okay. Question number 19. Given below are some algorithms and some algorithm design paradigms. List 1, list 2. Match the above algorithms on the left to the corresponding design paradigms they follow. Set zone. You should know job sequencing with deadlines concept to answer that question. We will see the maximum deadline and job deadlines. We will try to place the job at its maximum deadline. In that way, and also we compare the processing times, whether we have that much amount of time with us or not. Our target should be to complete more jobs. So that is what the problem of job sequencing with deadlines. So if you do not know it, please learn it. Yep. Here, do we have any that has dynamic programming paradigm that follow? Yes. 0, 1 knapsack is DP based. Effectively, you can try with greedy also, but it won't guarantee optimal solution. But all the other three, Huffman coding, the straw algorithm, minimum spanning tree, all are greedy based. So it is A2, B1, C2, A2, B1, A2, B2, C1, D2. So option D is the right answer. Option D. Okay. The last question, question number 20 today. Let G be a weighted, connected, undirected graph. Weighted, connected, undirected graph with distinct positive edge weights. If every edge weight is increased by the same value, then which of the following statements are true? P. Minimum spanning tree does not change. Q. Shortest path does not change. Yes. What is correct? Option C, neither P nor Q. Okay. What about others? Undirected graph. Yes. Undirected graph. Let us see. Just with a simple example, let us try. Suppose there is a graph with 3 vertices. A, B, C. Okay. Let their weights are 1, 4, 2. Here, what is the minimum spanning tree of G? Minimum spanning tree of G would be A to C, C to B. And what is the shortest path between any pair A to C? That's it. That A to C, that one only. B to C, that one only. But A to B, the shortest path becomes A to C, C to B. Right? Now, increase its weight, each edge weight by plus 2. So, it becomes 6, it becomes 1 plus 2, 3, 2 plus 2, 4. Here, what is the minimum spanning tree? It remains the same. Whether you follow Prim's or Kruskal's, it remains the same. But here, if you look at the shortest path from A to B, it is A to B only, not A to C, C to B. So, shortest path may change, but minimum spanning tree does not change. So, P is true Q is false. So P only. P only. Clear? That's all for today. This is my Insta and Telegram group links. Please do join if you have not joined yet. Let us solve 10 more good questions of algorithms at NIELIT level in the next session. Till then, have a great time. Thank you so much for joining. Keep preparing, keep learning, keep growing, guys. Hope this session is useful to you. If so, do like the session, share and subscribe to our BYJU'S Exam Prep YouTube channel and enable the notifications. Thank you, guys. See you in the next session. Till then, have a great time. Take care. Good night, everyone. Jai Hind.